Hi, everyone, and welcome to Workflow Optimization, the next frontier in healthcare. This is a BPM Plus Health virtual event that we organized this week to bring together the sessions and demos that members of BPM Plus Health had put together for the HIMSS conference that was unfortunately canceled. My name is Tracy Berardi, Program Manager of BPM Plus Health. This is actually our 7th session of the two-day event, Wednesday, Thursday of this week. And for those that may be new to BPM Plus, we launched this community back in September 2019. This is an open community initiative managed by the Object Management Group, which is a standards body located just outside of Boston, Massachusetts. And our goal is to improve the quality and consistency of healthcare delivery, and specifically for BPM Plus, our focus is on using open IT standards, business process and case modeling standards to model clinical pathways, clinical guidelines, and other healthcare knowledge. To basically to free this knowledge, to make it computer readable, computer consumable, so it can be shared across healthcare institutions and follow the patient, and ultimately at the end of the day help doctors and clinicians make better decisions, improve outcomes. So we thank you for joining us, hearing our message, and on the bottom of this slide, very grateful to founding members of BPM Plus that helped us to get this community off the ground. And we encourage you, if you're interested in getting involved, visit our website, bpm-plus.org. All this work that we're talking about in these sessions maps back to 5 working groups that we have launched: authoring, adoption, implementer, methodology, academic and professional education. We're really just getting these off the ground. We'll have a working meeting in a couple weeks that was going to be in Reston, Virginia, the DC area. Now it's virtual, of course, with coronavirus. But if you're interested, we'd love to have you. So now this session title is Knowledge Management, Using CDS Hooks in the Clinical Query Language as an Enabler for BPM Plus. There's a few speakers joining me on GoToWebinar. Bo Dagnall and Shane McNamee joined us again from Perspecta, Rob Reynolds, Dynamic Content Group, and Julie Shear with Motive Medical Intelligence. We'll have time for questions. We're going to try to save about 10 minutes if we can, so feel free to enter those in the questions box. And also in the chat is a link to the page on our website where we have the schedule of sessions and demos, and we're also posting the slides and the videos on demand as we have them. So I'm going to go ahead and turn the screen here over to Bo to get started. Thanks, Bo.
Great, thank you. All right, so thank you to OMG for giving us this opportunity to show what we would have shown at HIMSS. We actually have had 3 different sessions. This is the 3rd of our 3-part series on these OMG webinars. The first one was a review of BPM Plus model for clinical practice guideline for chronic kidney disease and how we were able to automate that as software and automate the delivery of data and knowledge within that. That has been recorded. If anybody missed it and is interested, you can find it. The second one was more of a deeper dive into our Health Concourse digital health platform, showing how we can pull data from different sources together, standardize those into FHIR resources, and then enrich that data through a variety of different services, and then use that data to drive knowledge, execution, and process automation. That one was also recorded. And this 3rd session is a deeper dive into knowledge management itself, how we go about authoring knowledge artifacts, publishing those artifacts, ingesting and discovering those artifacts in a real-time capacity, and then using those artifacts to learn more information from the patient's data in real time. So with that, I'm going to hand over to Dr. Shane McNamee as the first speaker.
Hi, everybody. Thanks for joining us here today. We really appreciate your time. Go ahead and forward for me. I'm going to be very brief here. Being a healthcare provider in today's data-heavy, information-poor world is really challenging. There's a tremendous amount of knowledge out there. They say about every 73 days, medical knowledge doubles. Staying on top of that is unbelievably difficult. Pushing best practices into workflows takes up to 17 years. And we're hampered very specifically by a litany of IT boundaries, where we would hope to have information such as the stage of my patient's cancer, a risk profile that changes daily across a cohort of patients, if it's a surgical cohort or others, to understand where you need to put your time, or really just getting in simple clinical decision rules that need to be calculated into workflow that would save providers time and help patients. Simply just doesn't happen in current healthcare here today, and it causes healthcare providers, number one, to miss the latest information, or number two, patients who we expect to have all of our healthcare providers to have this risk-heavy information and the latest clinical information at their fingertips. It isn't there. We go to Google, we go to Bing, and we find different calculators in different places outside of our workflows and try to inject that into there. Obviously, that isn't enough. Next, please. From a solution perspective, huge amount of standards are now moving into healthcare. FHIR, BPM Plus hooks, CDS hooks, CQL, and others. And then combining those with frameworks like one you're about to see, you can orchestrate a variety of different clinical decision endpoints and services and monitoring within workflow across patient populations to be able to identify high-risk patients early and intervene early, reduce the time for clinical decision support and knowledge to be injected into the workflow, all driving towards really a standards-based open IT movement to build a public health utility rationalized thing. We talk a lot about care without boundaries, which is the next age of health IT that we're moving into, but you can also look at that as knowledge without boundaries. So the ability to have up-to-date standardized data artifacts, knowledge artifacts, and knowledge services right there within the workflow of all healthcare team members, be it the patient, the doctor, the nurse, or whoever needs it. And that age is here, and we're really excited to show you the art of the possible associated with that. I'm going to hand over to my colleague, Rob Reynolds at DCG here now to take us forward. Rob, you might be on mute.
I was on mute. Thank you, Shane. To continue down that solution path, I'm going to get a bit techie and focus on the standards and how they're enabling unprecedented access to knowledge, and how Health Concourse is leveraging that to provide rich guidance to the clinician. The issue from the standards viewpoint is that clinical data accounts for around 30% of the total 2.5 quintillion bytes of data generated each day. And all this data exists in an astounding number of formats, which makes it difficult to ingest, especially in a timely manner. Additionally, as Shane described earlier, clinical knowledge is being produced at a rate that makes it impossible for clinicians to maintain working knowledge. In order to generate guidance from this overwhelming amount of data and knowledge, it needs to be automated. And for that to happen, they need to be represented and evaluated in a standard way. We need to use standardized data artifacts, knowledge artifacts, and knowledge services. Data artifacts are representations of data, and FHIR is a standard for representing healthcare data. It's not the only one. There are many competing standards, and you can't really say it's the best. That's arguable. But what you can say is that it has an extremely high level of adoption, and that's really what you want from a standard. On the left is part of the FHIR standard representation of a condition, and on the right is an example of a FHIR artifact representing data for a condition. And as you can see, the standard FHIR representation for a condition has an identifier, a clinical status, a verification status, etc. And on the right, you can see that the artifact representing the data has associated elements and values. You can see there's a resource type that says this is a condition, and a clinical status that for this patient has a value of active, and a verification status that has a value of confirmed. And if you jump down there to the bottom, you can see there's a subject that has a reference that has the patient's ID. That's how you know who this condition is for. Next. Knowledge artifacts are expressions of knowledge. CQL is a standard for expressing healthcare logic in a human-readable yet precise manner. On the left is an example of part of the CQL logic for expressing cervical cancer screening quality measure. As you can see at the top there, it says this is a library and it's using FHIR, and there's a parameter defined that is the measurement period, and it puts it in the context of a patient. And then it defines a numerator and a denominator, and the idea here is when this is run, the numerator is going to be divided by the denominator to get a score. And as you can see as well, the numerator is defined as there exists a PAP test within 3 years. And if you look at the definition of PAP test within 3 years down there a couple lines, you'll see that that is a PAP test with results where the PAP test effective date ends 3 years or less before the end of the measurement period. And if you look what a PAP test with results is, you'll see that it's an observation where the code for that observation is within the PAP test value set. And the PAP test has a value that is not null, and the status is in one of those options: final, amended, corrected, or preliminary. That's an abbreviated example of how CQL expresses logic, but it gives you the idea. On the right is an example of a FHIR artifact representing a knowledge artifact. As you can see, it describes at the top there, it describes it as a library, and there are a number of different elements there. If you go down to the type where the coding is, it tells you that this library is a logic library. And if you jump all the way down to the bottom to the content element there, you can see that the content type here is text and CQL. And the value says that this FHIR artifact can reference the CQL logic file or even possibly embed the logic within the FHIR artifact, allowing the CQL logic to be shared in a standard way. Next. Knowledge services are software services that use knowledge and data to generate guidance. There are a number of kinds of knowledge services, so there are a number of there are a number of kinds of clinical knowledge, so there are a number of kinds of respective knowledge services. But they're each useful, so they're complementary, not competing. On the right is an example of one kind of knowledge service, a CDS Hooks service. CDS Hooks is a clinical decision support knowledge service. A CDS Hooks service, one, is invoked by the EHR via an event configured in the EHR called a hook. Two, it evaluates its own logic within or with using FHIR data. And three, it provides guidance by returning decision support via things called cards. You can see an example of 3 different kinds of cards that it can return: an information card, a suggestion card, or a smart app link card. And these cards can contain a summary, a detail, and a suggestion, amongst other things. The suggestions in these cards are the guidance provided to the CDS, or the guidance provided by the CDS Hooks service. In this example, you can see that the guidance is try, a different medication instead. Next. Given these standards, imagine if all the latest knowledge related to something like chronic kidney disease, regardless of whether it's clinical decision support knowledge or quality measure knowledge or medical calculator knowledge or whatever, what if all that was available to the clinician at the time of determination of whether the patient is at risk for an emergent condition? What if all that relevant patient data was also available to the clinician at that time? And what if all that knowledge and all that data could be used to generate guidance for the clinician at that point in time so they could make the best determination possible? That's what Health Concourse and the Knowledge Manager does. It uses standardized knowledge services to apply the latest knowledge to the most recent patient data to provide guidance to the clinician. It also drastically reduces the time it takes for new knowledge to reach the clinician. As Shane mentioned, it can be up to 17 years to disseminate that. And it does all this in a shareable manner, so the same knowledge and evaluation can be employed across institutional, vendor, and geographical boundaries. So I just demonstrated where the industry is related to standards for sharing clinical data and clinical knowledge and producing clinical guidance. And now I'd like to hand it over to Julie to show a real-world example of how knowledge artifacts are used by knowledge evaluation services to produce guidance. Thank you.
Thank you, Rob. So now I will actually share my screen. So you should all be seeing sort of the Motiv knowledge artifact authoring system. So Motiv has developed a CQL FHIR based knowledge artifact authoring system that authors the types of CQL FHIR artifacts that Rob just talked about. So for example, within this authoring system, you can see on the left-hand side that we can offer rules, we can author measures, we can develop test patients. As part of that authoring process, obviously we have to start with a clinical base. So we also have the ability to curate and bring in evidence, update that evidence over time, and connect it to various knowledge artifact CDS rules, as well as measures. What we'll show you here is kind of how straightforward that can be, and really where the benefits of the standards from CQL and FHIR are enabling the industry and organizations such as DCG, Motiv, Perspective, Metal, and others to develop interoperable and shareable knowledge artifacts. So this is an example of one of the knowledge artifacts, CDS rules that we have that we are integrating in the Perspecta Health Concourse platform through their Knowledge Manager service. Just kind of as background here, we're seeing sort of the title of this. This is actually focusing on, it's a rule that focuses on identifying patients who have indications of chronic kidney disease. As part of that, obviously, we need an evidence base, and that evidence base is tracked through our level 2 artifact specification that you can see up here. For the purposes of this demo, I highlighted those here in our select evidence sources. So some of the evidence sources that are connected here are, for example, the Pocket Guide. And the artifact that we're looking at here is actually the one that would be attached here in step 5. Does patient have evidence of CKD? So the logic that we're about to look at is evaluating this particular step against patient data, and then would be returning the result of yes or no as an element of the service. So this is the artifact that Rob just talked about that is authored in CQL FHIR to generate that response when it becomes part of a service. So just for simplicity, or just sort of to provide some background, the diagnostic criteria for this is to we're identifying that a patient has a prior kidney transplant, that they have structural renal abnormality, or an EGFR that's less than 60. All of those criteria came from that guideline document that we just saw from the VA. One of the key elements of developing these kinds of knowledge artifacts, computable knowledge artifacts, is the ability to define the various criteria. And so as Rob just showed, he had a definition of a pap smear test. Here we have definition of EGFR tests, history of renal transplant, renal ultrasounds. These are connected to a terminology service on the back end, which then sort of enables us to define various value sets using standard terminology such as LOINC, SNOMED, ICD-10, RxNorm, to define sort of the criteria that are used as part of the logic. So here I have some that are defined as LOINC or as SNOMED within this example. Once we have the value sets defined, the next component is to then develop the logic and sort of demonstrate the logic itself. And so here is actually the area within the authoring tool, this Motive authoring tool, where we define the CQL logic. If I actually click this area, I can expand it, and I can show here sort of how that logic is determined. The final answer is whether a patient has indication of chronic kidney disease. We determine that answer by asking the question, does the patient have an identified decreased EGFR, or have they had sort of abnormal ultrasound? This logic from line 8 to line 27 is the logic that is looking for the decrease in EGFR. And as Rob pointed out, we start with reading sort of in a set of observations that are defined using that value set we just looked at, the EGFR tests. We then identify certain statuses that make those qualified EGFRs, and then we go about filtering based on the logic. And the logic that we have for this rule requires that we have at least 2 EGFRs, because we're looking for decrease here. 1 EGFR has to be within the last 30 days, and so that's essentially what this logic block is doing. And then the second EGFR has to be more than 90 days, right? So that's what this second EGFR is looking for. And then if we have any EGFRs in between, those also have to all demonstrate sort of the decreased value, which based on evidence is below the 60 milliliters per minute per 1.73 meters squared. So this is sort of another example of the logic as we go from the evidence, the description, the criteria, and then the value sets. We, as part of obviously as part of the authoring system, we can process the CQL. So here we're actually parsing it and making sure that it passes syntax checking. So for those of you who are technical online, you'll know this is essentially like a compiler. And here you can see the information about the artifact that would then be deployed. So the library name, the inclusion documents, the definition of the value sets, and then that logic that we just reviewed. And so then the final part about this is the action, right? So a CDS rule has the logic component and then the action component. To stay within standards and to make the actions interoperable, the authoring system defines an action as a FHIR resource. So here we can give a title to that action, a label, a description, but then we can also define it here lower down on the screen as being, we're creating an action of type condition. So this is a FHIR action. We can provide it with a codable concept. We can set statuses. All of these are what are then formed into the suggestion that Rob just talked about as part of the CDS hook. So when this rule is actually deployed into a service and evaluates patient data, when it fires or when the response is true, it will return this action within the suggestion. So now this is sort of how we author and test. We also have the ability to test our logic, obviously, against patient data. And then once the artifact is passes all the validation, we can just hit this button and publish it. This now publishes the artifact out to the knowledge service. And then at this point, it becomes available in the CDS service for third parties such as the Perspecta Health Concourse platform to interoperate with. So now I'll turn the presentation back to Bo, and he will show how that works from the Perspecta Health Concourse platform side.
All right, thanks, Julie. Okay. Great. So, to this point, we've seen, sort of what the state of the art and the standards and where the industry is going around this ability to author knowledge artifacts in standards-based ways and express them in computable syntax. We've seen how you can then use tooling to allow a knowledge engineer to, in fact, author algorithms and link the evidence to that, and then ultimately publish that up and package it as a knowledge service. What I'm going to show you is sort of the next step in the journey, which is how you then can discover and register those knowledge services so that it can be part of your platform, and then show you what the results look like on the other end. So to do that, you guys seeing my screen? I think you are, yeah. I'm going to switch over to, we've built an admin console that allows us to manage the knowledge services that are plug and played into the Health Concourse platform. Because we built the knowledge manager that Rob was referring to based on standards, we can in fact add as many knowledge services into that as we want to and do it dynamically. We can add them, we can change them, we can remove them. And as long as those knowledge services are delivered and exposed through a standards-based interface like CDS hooks, we are able to interoperate with those without any coding required, right, or any prior knowledge. And so what you'll see here on knowledge services page that I'm showing is a collection of knowledge services that we already have previously added into them. You'll see they come from different organizations. Motive was the group that Julie works with. We just saw hers. But we've also been able to ingest services from Microsoft, from TriZetech, from Medical Algorithms, from DCG, even some of our own. And what's neat about this is that each one of these organizations will go about creating knowledge services in their own way, using their own technologies, in their own expertise. You know, for instance, you just saw Motive does this with their tool set, and it generates clinical quality language scripts. I know from prior experience that you can create knowledge services as DMN models as part of the BPM Plus specification, and then publish those as CDS hooks services. Another very powerful way to do that. Microsoft actually had a really neat one. They have a machine learning environment where they created a supervised machine learning model using artificial intelligence techniques to train an algorithm to, in this case, to produce risk for whether or not someone has diabetes or not. And they sort of classify them as low, medium, or high risk based on a supervised machine learning model. And then they package that machine learning model into a CDS hooks service and expose it for us to be able to consume. So, you know, it doesn't matter how you got there. I mean, of course it matters, but the beauty is you can use the right tool for the job, the right technology for the job, and then ultimately package, encapsulate, and expose that through a standard, through CDS hooks, and then have a framework like ours with no prior knowledge, be able to use those and leverage those and apply them to the patient's data. So how that works is I'm going to add one now. So the first thing it's going to ask me is, you know, we organize all of our knowledge services first by what organization they came from. So for today, I'm going to say this is the BPM, you know, demo using the Motive MI service or whatever, right? So click next. Now our screen, you know, allows us to enter in details about the organization. I'm going to go ahead and skip that for now and get right to the endpoint. Now this is asking me for the RESTful endpoint, the URL of where that knowledge service was published. And I have that. Julie shared that with me prior. So here's the URL to that endpoint. And I can go ahead and add a new endpoint. I'm going to indicate that it's an active service. It's of various types. In this case, we are working with CDS hooks. It's communicating through JSON. And the URL is what I pasted in there, and it requires some authentication, a token. So I've got that already prepared as well. And I will paste that into there and go ahead and hit save and go to the next step. And this will then, what it's doing right now is it's going out to Motive's knowledge repository, interrogating that endpoint that was provided, passing through all the, you know, the security authentication, and then discovering which services are available at that endpoint. And here's that one that Julie just walked us through, right? So it discovered it. Now behind the scenes, you can't see this, but what happens is within the knowledge manager of Health Concourse, it's creating metadata about that service so that we can keep track of it and know how to use it. Every CDS hook service exposes data requirements in the form of prefetch queries. So what data is necessary to run this algorithm, and also exposes, you know, rules around usage context. And so we capture all that information, we store it in what's called a library, FHIR resource, and then we maintain that. And as data then flows through Health Concourse, patient data will be, you know, we have an index. We're looking for data that comes through. We're comparing it to the data that's needed by the various knowledge services that are registered. And if we have a positive match and we satisfy the usage context criteria, then we can go ahead and evaluate that knowledge service on the fly. And that happens behind the scenes. That happens without a human having to say, go do this for me, or, you know, or some other sort of external trigger. It's based on awareness of the data and whether or not the data matches the needs of those services. So you might have seen this on our previous demos. We have a UI that allows you to pull up a patient's record. I'm going to use May today. So this is now hitting the APIs of our FHIR repository. In that FHIR repository will be the patient's raw data, their medications, their conditions, and allergies, vital signs, etc. In addition to that, it will contain guidance response and measure reports and other sort of knowledge outcomes, right? The outcomes of these services are packaged up in the FHIR resources. So to give you a view of that, we have an alerts tab, and it shows you each one of these is the result of a knowledge service. And we have 5 here for this patient. The first one, the diabetic risk assessment, that's the one I was talking about a second ago from Microsoft. Right? This is the result of their machine learning algorithm that was trained using a data set, now being applied to the data that Mae Jackson has and determining whether or not she, what her risk is for diabetes. And the next 3 I know are from medical algorithms. And some of these are sort of standalone clinical decision support services. And some of these are more what they would refer to as medical calculators. And if you were to look on the calculators tab here, you would see that some of the results, what you're seeing here, are the results of what we showed you in the calculator itself. That's just another way of expressing knowledge as an algorithm and then delivering it through a standards-based interface. All the results, you'll see again are FHIR resources in their own right. This is that closed loop knowledge analytics engine, that capability that we're striving for, where not only is the data in FHIR, but you can evaluate the data against knowledge in real time and store the results of that as FHIR resources in the data set. When you hit the APIs, you get all of it. And this is what you're getting back as that FHIR sort of package of the knowledge outcomes. And then this one on the bottom, this one comes from Motive, right? This is the one around chronic kidney disease that we worked with Motive to create, and in using the process that Julie just explained to author the rule, to link the evidence, ultimately to publish that. We then discover it and make it available through this UI. Okay, so that's that demo. Let me switch back to the slides to wrap up a few points here. All that you've seen today with the Health Concourse platform is driven by this architecture. We really focused today on the knowledge, which is a yellow portion of this. So, but to get there, we had to have data, and that data came from a variety of different sources and different formats. We ingested that data, regardless of what format it came to us. It could have been a FHIR resource, it could have been an HL7v2 message or some proprietary API or data stream. We mapped and transformed that into FHIR because that is the canonical format. That's the one that Rob really focused on earlier in the presentation. That's what's used to then drive the computations. So we have to get it in FHIR first. Then we run it through the Knowledge Manager, where we can call the services that Motive has or Metal has or Microsoft has and evaluate the data and store those outcomes. In the demo yesterday, I showed how we can then use that information to automate decisions within a clinical practice guideline, like the one we have for chronic kidney disease or diabetes. And lastly, the APIs and the access mechanisms that we can provide for different applications, including the viewer that I just showed you, to be able to consume and show and work with those results. Underneath all of that is a lot, right? There's a core platform that does all the data orchestration, does all the security checking, manages the data as it flows through the system. It's really the intelligence of the platform, and it provides the cohesion that allows all the different technologies to fit together. And it leverages a variety of services following a service-oriented architecture approach, where we leverage the best technologies for the job. And we have these 10 different services, and this list of services always grows as we discover new capabilities or new technologies. We can add them into as we need to. And some of these are a mix of open source things like CTAKES is open source and MDMI is open source. Some of these are proprietary products like the Wolters Kluwer terminology engine and the IMO precision summary engine. And it doesn't matter, right? As long as you encapsulate those inside standards-based interfaces and then plug and play them into the appropriate place within the orchestration of the platform, they can all work together. And that's really the goal. So the tie back to BPM Plus is that when you take a human readable artifact like you see the clinical practice guideline here published by the VA for chronic kidney disease, you can then express this as a BPM Plus model. And this is taken what was a human readable form to something that's now both human and machine readable. That's the power of BPM Plus. You can now run this as software. And when you run this as software, you'll find that there are certain decision nodes along the way that can be automated by aligning them to a knowledge service, right? So there's a question in here: does the patient have an urgent or emergent condition? And the second question was, does the patient have evidence of chronic kidney disease? This third one is determine the stage of chronic kidney disease. And this last one is determine whether or not you need to refer out to a nephrologist. Those could all be answered by humans, of course, but if we have algorithms and clinical decision support that can automate some of that and take the burden off the human, we can align those knowledge services through the knowledge manager and assign them to the appropriate decision nodes in the BPM Plus model. The closing thought on this is that the whole architecture is really a collection of different technologies and companies working together. It's very much embracing the best of breed strategy, where we don't believe that any one technology or any one company should try and solve this very complex problem on their own. It's very dynamic and evolving, and you need to be able to have a certain degree of plug and play. And standards are really the way in which you do that, right? Standards-based interfaces, service orientation, platform architectures allow that cohesion to exist across a heterogeneous collection of technologies. And to prove that to you, here's the different companies that we worked with to show you the demo we showed you today. And then their logos are overlaid on top of where they sort of fit within the overarching architecture. So I'd like to provide attribution and kudos to all these companies who put time and effort into making this a reality. And with that, we'd like to close and open it up for any questions.
Great. Thanks, Bo, everybody. Now's a great time. Yeah, if you have some questions, we do have one in the queue. Let's see. Okay, and there's another one. Great. How many current EHRs are running the platform that you showed today in a clinical setting?
Shane, do you want to take that?
Yep, very easy answer. Answer is 0. The product is coming to market as we speak, deployed onto Azure Marketplace June 1st this year, and will be on AWS thereafter. So it's just in the final throes of release at this point, and will be out in the general public here in the next couple of months.
Awesome, thanks. Excellent presentation, very much needed, so kudos to you guys, gals. CDS hooks was not mentioned in the final rule that came out Monday. Have you seen EHR vendor adoption in production of CDS hooks beyond pilot projects? Can you cite the number of sites using CDS hooks in production or other metrics to get a sense of adoption?
So Julie or Rob, do you want to take that one?
This is Brent. I can take a stab. I can tell you that Epic has had CDS hooks production available for quite a while, and they're expanding that support. I don't have numbers on actual, that would be a production usage, but I imagine there's some, given that Epic's had it available for a long time, and there are many services that make that available.
Yeah, so Bryn, I can also answer that. So from a knowledge services provider perspective, we've integrated using CDS hooks with most of the major platforms today. So I'd say CDS hooks is definitely one of the mechanisms we're seeing in production. I think one of the aspects of the market and of the industry, the community that we're seeing evolve is kind of the FHIR version in which the CDS hook is written around. The fact that the coalescing is now around FHIR 4, we believe will drive even more adoption in production, or I should say push to production, the use of CDS hooks, because FHIR 4 is in many ways a much better standard for doing the kinds of knowledge services that we are looking at, that we demonstrated today. We are also seeing on the other side sort of the growth of interoperable CDS, so where the artifact itself is then moved to another platform and run in another service. So I would say the implementation of these standards in production is increasing rapidly, and we do believe that we'll continue to see that increase over the next 12 to 18 months.
Great. That was helpful. Any other questions? I'll just, while we pause for a second, just a friendly reminder, we are capturing all the recordings from these sessions yesterday and today. The link that you can find these, it's in the chat box. Go to webinar. We have the schedule, and you'll see that we have videos and slides from Wednesday, and we'll get today's presentations up by morning time tomorrow. There's one more session after this with Jane Shellham, Mayo Clinic, using semantic DMN to represent the logic for cognitive support tools. That'll start in about 20 minutes if you'd like to join us. But it looks like that was the end of the questions. So thank you, Bo, Shane, Julie, Bryn, Rob, for hopping on, and everyone for tuning in. We'll see you again soon. Have a good rest of the day. Thanks.
Thank you.
Thank you.
Thank you.